Okay, so in part one of our notes, we talked about evaluating for specific numbers. Now we're going to make this a little more generalized, and we're going to evaluate given different variables. We're going to perform the same operations that we did before, but it's going to be a little bit more complicated, right? Because we're going to be working with expressions instead of numerical values. So if I want to take f plus g of x, okay, I'm going to think of that the same as I did in the day one notes. I'm going to think of that as taking f of x plus g of x. Okay, so now that means that I'm going to take the entire function f of x, which is x squared plus 3x minus 10, and then I'm going to add to it the entire function g of x, which is x minus 4. Now this one's rather easy to add together, because we're just going to combine like terms. So we get x squared, 3x and 1x makes 4x, and negative 10 minus 4 is negative 14. So f plus g of x is x squared plus 4x minus 14. Now the second part of what we want to do is we want to make sure that we're aware of the domain on our function. Okay, and this is kind of an extension, so if this is something that you're struggling with, don't worry too much about it. But when I think about this function, x squared plus 4x minus 14, we know that that's a quadratic, right? And so when we think back to our quadratic unit, our quadratic's domain happens to be all real numbers, right? So in this case, we're thinking, are there any restrictions on what I can substitute in for x for this particular expression? And there really isn't. Okay, so let's try number 2. So now we're going to try h minus g of x. So that's going to be rewritten as h of x minus g of x. So now I'm going to look at the function h of x. So that's 2x minus x squared. And I want to subtract all of g of x. So now this is where this gets a little more complicated, and students tend to make mistakes. I'm subtracting the entire quantity x minus 4, so because I'm subtracting all of it, I'm going to make sure I wrap that in parentheses. And then what's going to happen is, in order to simplify this, I'm going to have to distribute that negative sign. So it's going to be negative x and then positive 4. And then I go ahead and rewrite this, combining like terms. That's negative x squared, 2x minus x is 1x, and then plus 4. And again, if I think about the domain here, the domain is going to be what numbers can I substitute in for x to this quadratic? Again, it's going to be all real numbers. Now, if we recall from first semester, when we write all real numbers, we can write negative infinity to positive infinity if we were to use interval notation. Okay, so either one of those is acceptable for you to write all real numbers or negative infinity to positive infinity for your domain. Okay, number 3, I want to take f of x divided by g of x, right? So that's just taking f of x divided by g of x. I actually like these ones the best as far as the evaluating part. The domain gets a little bit tricky, but so f of x is the function x squared plus 3x minus 10. Divided by g of x is the function x minus 4. Okay, now this, when I look at this particular function, if I were to identify the domain here, okay, it's really important for me to think, are there any restrictions on this particular expression? Well, when I think about restrictions with division, I know that I cannot divide by 0, right? So I'm going to write a little note here, and I say I cannot divide by 0. So in other words, this value can't equal 0. So x minus 4 cannot equal 0, which means x can't equal 4. So my domain is all real numbers except 4. In interval notation, if I were to write that, I'd go from negative infinity up to 4, and then I'd go from positive 4 up to positive infinity. Okay, it's also perfectly acceptable for us to just write all real numbers except 4. Okay, and now I'm running out of, I need a little bit more space here, so I'm going to make this a little bit bigger. So if I want to do g times h of x, right, I'm going to erase this up here so that this is not as messy. Okay, so g times h of x is going to be me taking g of x, and I'm going to multiply that by the h of x. So g of x is the quantity x minus 4. I'm going to wrap that in parentheses because I want to multiply the entire quantity by whatever h of x is. Okay, and then I'm going to multiply that by h of x is the quantity 2x minus x squared. Okay, and we know how to multiply binomials with each other. So if I were to multiply this out, I get x times 2x is 2x squared. X times negative x is negative x cubed. Negative 4 times 2x is negative 8x. And negative 4 times negative x squared is positive 4x squared. Combining like terms, that gives me negative x cubed. 2x squared plus 4x squared is positive 6x squared. And then minus 8x. Okay, and I think to myself, if I'm going to identify the domain on this guy, are there any numbers that I wouldn't be able to substitute in for x, or are there any restrictions on this function? Okay, and this is a polynomial, a cubic polynomial, so if we think about what those look like, we know that there's really no restrictions on x, so I can put in all real numbers for this. Okay, we got two more. Number 5, 2 times g of x plus f of x. Okay, so g of x is x minus 4. So this I want to do 2 times the quantity x minus 4, and then plus f of x is x squared plus 3x minus 10. So plus x squared plus 3x minus 10. I'm going to combine like terms here. So 2x minus 8 plus x squared plus 3x minus 10. I get x squared plus 5x minus 18. And again, if we think about this as a quadratic, the domain on this is all real numbers. All right, let's do one more example and then call it a day. I actually like number 10. Okay, so number 10 says find h of 3 of x, or h of 3x. So I'm looking at h of x. And if I want to find h of 3x, that means that I'm going to replace all of the x values with the quantity 3x. So h of x, I'm going to rewrite it down here because I need to look at it at the same time. So h of x was 2x minus x squared. Okay, so if I'm going to evaluate h of 3x, what I want to do is I want to replace all the x's with the quantity 3x. So this is going to look like this. 2, instead of x, I'm going to write 3x. Minus, instead of x here, again, I'm going to write 3x. So this is the quantity 3x squared. Okay, and then when I evaluate that, I get 2 times 3x is 6x. The quantity 3x squared is 9x squared. And so 6x minus 9x squared is my final answer. If I think about the domain, again, this happens to be another quadratic, so this will end up being all real numbers. All right, I'm going to go ahead and let you guys get started and start practicing with that.